Question number 3, draw a polygon of constraints that corresponds to the solution set of the following system of inequalities. We've got these inequalities. I'm going to start with my b value is 12. That's right here. The slope is -1/2. The delta y is -1, and the delta x is 2. From the 12, I'm going to move over 2, 1, 2, and then down. It's going to go through the 12, and through that point, we have a line like this. It's solid because it's less than or equal to, and because it's less than, I'm going to be shading below. The next one, y is greater than 1/8 x plus 2. So my b value is 2. Right here, my slope is 1/8. So my delta y is 1, my delta x is 8. So I'm going to move over 8 and then up 1 like that. So I'm going to go through that point and my b value 2. It's dotted because y is greater than, it's not equal to. And because it's greater than, we're going to be shading above. The next one, y is less than or equal to 5/2 x. The b value is 0. There's no b value. So it's going to be going through the origin. The slope is 5/2. The delta x is 2. The delta y is 5. So I'm going to move over 2 from the origin, over 2 and up 5. 1, 2, 3, 4, 5. So it's going to go through this point as well. It's solid because y is less than or equal to, the equal to bar says solid bar of a line. Because it's less than, I'm going to be shading below, so I'm going to be shading down here. Then we have x is less than 8. Now x equals 8 is going to go through the x-axis at 8, and it's a vertical line, so it's going to go up like this. It's dotted because it's less than, and because it's less than, we're going to be shading towards the left, because all the values of x that are less than 8 are found to the left of this line. So that means this is our polygon of constraints right here. Determine the vertices, the coordinates of the vertices of the polygon of constraints, so the corners of the polygon of constraints. So I'm going to start with this one. We can read it right off the graph. It's 4, 10. The next one is 8, 8. This one is 8, 3. This one we're going to have to calculate. It's a little bit less than 1 in terms of the x and a little bit more than 2 in terms of the y. We're talking about these two lines. This line is 1/8 x plus 2. And that line is y is equal to 5/2x. Now 5/2 is 2.5. I'm going to start with my 1/8 x plus 2. 1/8 is 0.125. So I'm just going to rewrite that as a decimal. 0.125 x plus 2 is equal to 5/2x, which is 2.5x, which is bigger. The 2.5 is bigger. So I'm going to subtract that 0.125 from the left-hand side. And when I do, it's gone. But I also have to remember to subtract it from the right-hand side. 2.5 take away 0.125 gives us 2.375. We're left with 2 is equal to 2.375. I want the x all alone. The 2.375 is stopping it. It's multiplying the x, so I'm going to divide both sides by 2.375. 2 divided by 2.375 is going to be something a little bit less than 1, which is 0.8421. I'm going to feed that back into one of my equations. This one's a little bit easier, the 2.5x. I'm going to feed it into the y is equal to 2.5x, which is this one really. Y is equal to 5/2x. But same thing, 2.5, 5/2. Y is equal to 2.5 times the x value, which is the 0.842. And this is not really 0.8421. It goes on forever. Let's have a quick look at the handy-dandy calculator for that one. 0.842105, and it goes on forever. But I'm just rounding it to 4 decimal places. So if we multiply that by 2.5 times 2.5 gives us 2.10526, and it goes on forever, but I'm going to round that to 2.1053. That's our point. Here's our point, 0.8421, 2.1053. Then indicate for each vertex of the polygon of constraints whether it belongs to the feasible region or not. I'm going to start with this one. It's on a two solid line, so it's part of the feasible region. This one, no, it's on a dotted line right here. It's on a solid and dotted because it's on a dotted, nope. This one, it's on dotted and dotted, so double no. This one, it's on, that's dotted as well, so no. All of the vertices of the polygon constraint, except for the 410, are not part of the feasible region. The 410 is. D, determine whether the graphical representation corresponds to a bounded or unbounded polygon of constraints. This is bounded. The yellow isn't running away. And even if this line wasn't here, it would still be bounded because eventually the yellow would, like this line would eventually meet that line and the yellow would stop here. This is a bounded polygon of constraints. It's all held together. Think of this as a fence. The yellow can't get free.